There we go.
There. You're muted.
Welcome back, even though you're muted.
My
Okay.
internet must have just gone out or something, or I don't know. It's something weird happened. So what problem was I in the middle of?
Oh, you were doing F.
Oh, okay. So y'all didn't miss much then. But the problem is that it started saying to record or save it or something, and I think I just lost the whole recording. Urgh.
Let's restart the entire lesson.
Let's see here. Okay, so I had just started F. Did you see any of that?
We have the you all. This is exactly where you left off.
Okay.
Oh, a tiny bit forward, but it's not much at all.
Okay, that was weird. I don't know what happened. I live out in Crandall, Indiana. I don't know if y'all know where that is, but I'm kind of triangulated between Corydon, Georgetown, and New Salisbury. It's kind of dead in the middle there. There's like maybe 250 people that live here, and we have a post office though, so we have a town. But I don't know, every once in a while my internet just does weird shit. So, well, crap, I don't know how I'm gonna save the beginning. I'll have to re-record it later, I guess, myself. Okay, that'll be great. All right, so I was on F, and I was taking the x plus 2 and squaring it. That's what I was trying to do here. And x plus 2 times an x plus 2 is going to give me a trinomial of, first times first is x squared. My outsides would be a 2x, and so would my insides. So altogether, my middle would be 4x. And then last times last, 2 times 2 is 4. And then I'm just going to copy the rest of this down. So I started with my exponent and I FOILed it. And now I am going to distribute the 4 here. So that's going to be 4x squared plus 16x plus 16. And then I'm going to distribute the 4 here. So that's going to be 4x plus 8. And then I still have that minus 2 on the end because he was not inside any parentheses. So first I FOILed, then I distributed, and now I'm going to combine like terms. And I only have one term that's an x squared, so he's first. I have a 16x squared and a 4x squared, so I'll combine those. And that'll be, did I say squared? I meant x. I don't know what I was saying. I have a 16x and a 4x, so I got 20 x's all together. And then, what else have I got here? How about some pink? And then I can combine the 16, the 8, and the minus 2. That'll combine to be what? 16 plus 8 is 24, and 24 minus 2 is a 22. And that is my simplified answer to F. I think I'm going to have to insert another slide here. Sorry. And a blank one. And can I copy this? Copy, paste. There we go. All right, so now I have to do G. G is f of 4x. So this is going to be 4 times a 4x squared plus 4 times a 4x minus 2. I'm still going to start with the parentheses, and I'm going to take a 4x and square it. Well, a 4x times another 4x, and then times that 4 in front of it. 4x times 4x is a 16x squared, and then when you take 16 times 4, it's 64x squared. And then 4 times 4x is just 16x, and then minus 2. And none of these are like terms, so you're going to leave it just like that. Now, H. H is the fun one. Not that we haven't been having fun already. H wants you to calculate f of an x plus h. I meant to do that in a different color. Sorry about that. Dark green. Okay, so instead of 4 times x squared, it's going to be 4 times x plus h squared plus 4 times x plus h, and then you got a minus 2. Now you're still going to start with your x plus h squared, and I'm going to do that up here. Okay, so you're going to start with first times first. First times first is x squared. Then you're going to do your outsides. Well, x times an h is an hx if I put them in alphabetical order. And then if you do the insides, you get another hx. And then last times last is h times h, which is an h squared. So down here, I'm going to have x squared. My middle term will be plus 2hx. And then my last term will be plus h squared. And then I just use my copying skills for the rest. All right. That was probably the hardest part, because from this point on, it's just distributing and combining like terms. So I'm going to distribute the 4 to all of this. That's going to give me 4x squared plus 8hx plus 4h squared. And then I'll distribute this 4. That's going to give me 4x plus 4h. And then I still have that minus 2 hanging on the end. Okay. So, I don't have any like terms. I don't know why I put the equal sign there. There are absolutely no like terms. This is my answer. It is ugly. Have fun typing that into MyMathLab. But there are no like terms.
Would the 4h squared have to change places with the 8hx because it has a higher vector, or not a vector, but a higher exponent?
No. What you're thinking about is when it's the same variable, like x to the 5th, x to the 4th, x to the 3rd, x to the 2nd. When
Gotcha.
it's a multivariable like this, there is no real organization to it.
All right.
Yep. You just leave it. All right. So that was fun. All right. And then they move into the next objective, which was finding the domain of a function defined by an equation. And I eliminated their examples and just went straight to the rules, and then I'll teach it to you as I do the MyMathLab instead. Okay, so basically you're going to start with the domain of the set of all real numbers, which goes from negative infinity to positive infinity. However, if the equation has a denominator, you have to exclude any numbers that would give a 0 in the denominator. Like that previous problem, I think it was like 4 over x minus 3. That was the function they gave us earlier. On this one, x can be anything except for 3. X is not allowed to equal a 3, because if you stick a 3 in there, you're going to get 4 over 3 minus 3, which is 4 over 0, and you put that in your calculator and it goes, ee! Gives you a big error message. You cannot divide by 0. And since they want this in interval notation, you would say, okay, we're starting at negative infinity. We're going to come up to the 3, but not include the 3. So you use a parenthesis. That means you're getting up to 2.9999999, but you never get to 3. Then you're going to have to use this little symbol, which is the union symbol. And then you're going to do another set of parentheses and put a 3 after that, and a comma, and positive infinity. This is the way you say x can be anything from negative infinity to positive infinity, except for the number 3. And the reason I know that is because you've got parentheses on this side of the 3 and parentheses on that side of the 3, which basically is saying you can go up to 2.9999999, and then on the other side it's like 3.000000001, you know? So that's if you have a denominator. All right, that was this thing, denominator. And then the other one is if the equation has a radical. And a radical could be a square root or a cube root or a fourth root. I'm sorry. A radical of an even index. That's right. Cube roots, you can have negatives, so there's no problems there. You have to exclude any numbers that cause the expression inside the radical, also known as a radicand, to be negative. So if you had an equation that was like y is equal to the square root of x minus 5. I'm looking at this and saying, whatever number that I plug into x, it can be anything as long as it doesn't result in something negative. So the x minus 5 has to be greater than or equal to a 0, because you can take the square root of 0. The square root of 0 is 0. So to solve this, I would add 5 to both sides. And that's going to tell me that x has to be greater than or equal to a 5. So right here, I can plug in 5. 5 minus 5 is 0, and the square root of 0 is 0. I can plug in a 6, I can plug in a 7, I can plug in an 8, I can plug in a 9, a 10, 152, whatever, it doesn't matter. Because as long as x is bigger than this 5, when I subtract, the crap I have left over will be positive, and I'll be able to square root it. But I couldn't use 4 or 3 or 2 or 1, because those numbers minus 5 would give me a negative, and the square root of a negative takes us to imaginary land. So this is my answer, but in interval notation, because it's an equal to, you have to use a bracket, and then you'd say 5 comma, and then it goes to infinity, and you always use parentheses on infinity. So those are the two things you have to watch out for. So on the first one, Mymathlab number 12, it says find the domain of this function. It's just negative 7x plus 6. There's no fractions, there's no radicals. So my answer is negative infinity to positive infinity. It wants it in interval notation. But when I get to number 14, I have a denominator, okay? For the fraction ones, the denominator is not allowed to equal 0. The x squared minus 9 cannot equal 0. So solve that for x, and you'll know what x is not allowed to equal. So to solve this, I'm going to add 9 to both sides. Cancels that. I get x squared is equal to 9. And then, of course, to solve for x, I would have to square root both sides. This is a quadratic equation, so remember there are two possible answers, either a positive or a negative 3. Because if I stick either one of these where this x is, positive 3 squared would be 9, minus the 9 would give me a 0 on the denominator. If I plug in a negative 3, negative 3 squared is positive 9, minus the 9 is another 0 on the bottom. So x is not allowed to be 3 or negative 3. Now the way you have to write that in interval notation is going to be, you start at negative infinity, you come up to the negative 3, that's smaller than positive, negative 3, but don't include it. Then you put that union symbol. Then on the other side, you'll continue on the other side of negative 3, and you'll go up to the positive 3, but don't include that, unioned with positive 3 all the way to infinity. And if I were to draw this on a number line so you could actually see it, because I'm a visual learner, I'm going to do my number line up here. Here is negative 3 and here is positive 3. It's like you have an open circle here and an open circle there. It goes up to that but doesn't include it. Then you've got this, doesn't include the 3, and then you've got that. So it's kind of like if I highlighted it, this part is this interval. This part is this interval. And this part is this interval. There's 3 intervals there. Going from negative infinity up to negative 3, going in between negative 3 and 3, and then going from 3 to infinity. 15 has find the domain of this function, but this one has a radical in it. So for the radicals, you have to say, okay, the 2x minus 18 has to be greater than or equal to 0, because under a radical, you can't take the square roots of negatives. So I would add 18 to both sides, divide by 2, which means x has to be greater than or equal to 9. So because it's an equal to, I would start with the bracket, put my 9, put a comma, and then go to infinity. And that's my answer. And then there's 17, which has both a fraction and a radical, and you have to consider both. I know the radical's in the numerator, but it doesn't matter. It's just there's a radical in the problem. So because of the radical, you have to make sure that in this case, your t can't cause a negative, and your t also cannot cause a 0 in the bottom. So I have to do both of these separately. I'm going to start with the bottom here. The denominator is not allowed to equal 0. So if I add 21 and divide by 3, oh, that's right. 21 divided by 3, that's 7. Okay. First of all, t is not allowed to be a 7. But then I've also have to deal with this guy. The square root of t minus 4 tells me that the t minus 4 has to be greater than or equal to 0, because if it was less, it would be negative. And if I just add 4 over, t has to be greater than or equal to 4. All right. I'm a visual learner. Here is the 4. And here is the 7. And they're saying that it can be greater than or equal to 4, going this way, but it's not allowed to be 7. So that's what I'm looking at. I actually see 2 intervals on this. The first one I see is here. It goes from -4 up to the 7. So I would go bracket 4, comma 7 parenthesis. Then I do a union. And then on the other side, it goes on the other side of 7 and keeps going to infinity. And that is what this is doing over here. And that's this interval. Hope that helps you see it. Okay. This is a long section. I am not going to get this finished, but all right. And then the next objective was form the sum, difference, product, and quotient of 2 functions. Remember that a sum is what you get when you add. A difference is what you get when you subtract. A product is what you get when you multiply, and a quotient is what you get when you divide. Math talk. All right, so if you see, find the sum of f plus g of x. If you see it written like this, f plus g in parentheses of x, it's basically saying take the f of x function and add it to the other function which they've labeled g of x. And then the same thing for subtraction. F minus g of x simply says take your 2 separate functions and subtract them. F times g of x means take the f of x times the g of x. And then f over g of x means take f of x divided by g of x, except you have to remember that the denominator is not allowed to equal 0. It's easier than it looks. So let f and g be two functions defined by f of x equals 1 over x plus 2, and g of x equals x over x minus 1. And first they want you to add them, then they want you to subtract them, then they want you to multiply them, and then they want you to divide them. And they showed all their steps here, which are obnoxiously long. Before you can add fractions, you have to have a common denominator. So since the first denominator was an x plus 2, and the second denominator is an x minus 1, your common denominator would be the two of them multiplied together. So since the first one had the x plus 2, but did not have the x minus 1, you had to multiply top and bottom by x minus 1. And then the second one had the x minus 1, but it was missing the x plus 2, so you multiplied top and bottom by x plus 2. And then, of course, once you do that, your common denominator just is written over here. And they distributed this x to the x plus 2. That gave them x times x is x squared. They had a 2x here plus the 1x there, which gave them the 3x. And then the minus 1 is what was left. And that was their answer. And they had to put in the stipulation that the domain can be anything but -2 or +1, because -2 would cause a 0 here, +1 would cause a 0 there. And then they went through and did the rest of them. What I want to do is jump to the Mymathlab example so you can watch me work through one instead. So given these two functions, find f plus g of x. So remember that f plus g of x really means take f of x and add it to the g of x. And f of x was an x minus 3, so I just put x minus 3 right there, plus g of x is a 3x squared. So right here I put a 3x squared. And then I would add them together. Unfortunately, there are no like terms. So me being the algebraian that I am, since this is a single variable problem, I would put them in descending order. I don't think Mymathlab cares, however. All right, so that's the answer that goes in this box. And then they ask you for the domain. Use integers or fractions for any numbers in the expression. Use a comma to separate answers as needed. It looks like they're using set builder notation, not interval. They didn't ask for interval. So they've got the domain is x such that x is any real number. I'm sorry, that would be choice B. Yeah, there are no stipulations on it, so it's just any real number. There's no denominators that I have to worry about with a 0. There's no radical that I have to worry about with negatives. Any number will work. Now this one says f minus g of x. That means you're going to take f of x minus g of x. And again, f of x, I didn't copy the whole thing, did I? Sorry. F of x was x minus 3. So x minus 3 goes there. Minus g of x. And g of x was a 3x squared. And none of those are like terms, so you can just put it in like that into Mymathlab. because there's no like terms. Or if you wanted to put it in descending order, you'd put the minus 3x squared first, a plus x second, and a minus 3 third. I don't think Mymathlab cares. And once again, the domain would be any real number. Anything from negative infinity to positive infinity, any real number, fraction, decimal, whole number, positive, negative, no problems. All right, and I am right at the 5:15 mark, so I'm gonna stop. Oh my gosh. I guess I'm gonna have to do a whole new recording. I guess. Let's see, somebody's chatting with me down here. Oh, muted. I guess I'll just have to sit and do a whole recording on my own later tonight and post that in on YouTube, because I don't know what happened, and I guess I should have hit save recording and I didn't. So live and learn. Does anybody have any questions about anything before we sign off?
None from me.
All right, well, I'll finish this next time and I'll have your 3.2 video or PowerPoint up also. Bye.
I need to get going, man.
Bye.
Bye.
Bah.
Bye.